Hello everyone. In this video, we want to take a look at 6217 packet tracer configuring VLANs. First, objectives are verify the default VLAN configuration, configure VLANs, and assign VLANs to ports. In part 1, display the current VLANs. On switch 1, issue the command that displays all VLANs configured by default. All interfaces are assigned to VLAN 1. Yes, we know that by default, all interface assigned to VLAN because VLAN 1 always is always open and on and active, and you can see this show VLAN brief this command here, and you can see all of the ports and interfaces a member of VLAN 1 and is active and by default. Yes. And it as in the same in switch 2 and switch 3 and all of the Cisco switches. Verify connectivity between PCs on the same network. You can see PC1 and PC4 at the same network, PC2 and PC5 at the same network, and PC3 and PC6 at the same network. It means 172, 17, 30, and is the same, you can see here. And also for PC1 and PC2. And in this situation, PC1 can ping only PC2, PC4. Ping PC4, 17, 10, 24. And they can ping. Yes, they can ping each other. And also PC2 can ping PC5 because they are at the same network, and in layer 2 they can ping together. You can see this one also. Yes, and it's same for PC3 and PC6. You can check it. Yes, ping to PC in or other network fail. Yes, because PC1 cannot ping PC5 because they are not at the same network, and also there is no router here to make connection in layer 3 and make and create a routing protocol between them. In this situation, for example, PC1, we can see PC1 cannot ping PC5 in layer 2. Yes, switch cannot make any connection and any routing protocol between them. Okay, in this situation, we need to have a VLAN. Okay, what benefit will configuring VLANs provide to the current configuration? VLAN solves a broadcast problem. VLAN reduce the size of broadcast domains because we have broadcast domains here, and also allow the user to add an additional layer of security and make device management simple and easier. And there are a lot of higher performance and reduced latency and removes physical boundary and let you easily segment your network. And there are so many benefits and advantage for using VLAN. Configure VLANs. Create and name VLANs on switch 1. On switch 1, we should go here and go to config mode, and create all of the VLAN here. Create VLAN 10, and name should be this one. VLAN 20, and name should be student. VLAN 30, and name should be this one. And VLAN 99, and name should be management. Yes. Which comment will only display the VLAN name, status, and associated ports on switch? Yes, you should write show VLAN brief. In the config mode, you can write also do plus other command in privilege mode, and you can see output is here. You can see name of VLAN, VLAN number 1, 10, 20, 30, and 99 that we have created, and also the name, and also a status, and also which ports uh, and which ports is member of VLAN 1 and assigned to VLAN 1. Yes, you can also see. Uh, create the VLAN Create the VLANs on switch 2 and switch 3 using the same command from step 1. Create and name the same VLANs on switch 2 and switch 3. Okay, we should go to switch 2 here and write enable and conf t. Excuse me. Conf t, yes. And we should write here also VLAN 10 and same name. And it's very important in all of the switch in the network, we should have same VLAN name and same VLAN number. It's very important. Yes, unless it will be happen any conflict between VLAN. Yes. And also the same, and do WR to save it. And also here, enable CAFT VLAN 10. Name should be this one. VLAN 20. Name should be student. Yeah, rename it student, and VLAN 30. Create VLAN 30 by the name this one, and VLAN 99 is native VLAN. And after that, we can focus on the types of VLAN, native, management, and other thing. Okay, do WR. And other step, verify the VLAN configuration. How to verify? You should right here do show VLAN brief. You can see. Also, you can see here show VLAN and other option with a question mark. For example, name. Only students I want to see. Students. Yes, this one. Also, VLAN 20 and NTU and other information as active and name and information about that. Assign VLANs to the active ports on switch 2. We should assign the VLAN to interface. For example, in switch 1, assign VLANs to the active ports on switch 2. Excuse me, switch 2 exit. And right here, we have interface master ethernet 011, and you can see switch port access VLAN 10, and also 18 should be 20, and 0 should be Yes, this is 30 should be. Yes. Assign VLANs on the active ports on switch 3. Also, you can write here conf-t and interface master ethernet 011 and switch port access VLAN 10 and should be assigned to 018 and also VLAN 30 assigned to 0 and do WR to copy it. Assign VLANs to the active. We have done it. Previously, PCs that share the same network could ping each other successfully. Try pinging between PC1 and PC4. Okay, we should try to do that. PC1 cannot ping PC4. Before that, they can ping each other, but no, PC1 cannot ping PC4 because no VLAN works for us, and they are at the same VLAN. PC1 and PC4, PC2 and PC5, PC3 and PC6, same VLAN. But problem is between switch 2, switch 1 and switch 1, switch 3, uh, there is no VLAN between them, and they are their ports are assigned to access mode, and access mode cannot pass 2 or 3 or a lot of VLAN over. In this situation, we need to have trunk. Trunk can pass over a lot of VLAN, and it's the differences between trunk and access. For example, you have VLAN 10, 20, 30 here, and you should pass over here, and they are should be member of trunk, and we should configure trunk for G11 and G11 or switch 1 and switch 2, and also here for switch 1 and switch 3. And this is the solution. What could be done to resolve this issue? We should use and we should activate trunk between these switches and under interfaces. And in the next video, we can check it and we can resolve it. Thank you for watching.